we're going to look at read and interpret data in line graphs and pie charts. So we're going to look at line graphs first, and then we're going to look at pie charts. Okay? So, we've got a line graph of information about people who watch different television programs. We've got the information at the bottom, which is the thing that you change, and then the information at the side, which is the thing that you measure. Good. And the information at the bottom needs to be what? What do you need to remember with the information at the bottom? It needs to be
equal.
Yes, good. Regular intervals, equal intervals. Yeah? You can't jump 3 hours and then half an hour and then another 3 hours and then 2 minutes or whatever. It needs to be nice regular intervals. Good. And then you choose a suitable scale for up the side. In this case, it's number of viewers. Ron and Annie watch the same channel but at different times. The graph shows the number of viewers at different times. Ron watched Chums at 5 o'clock. Annie watched Count Up at 8 o'clock. What is the difference between the number of viewers at the start of each programme? So, at the start of Chums, which is 5 o'clock, let's look really carefully. It's got the line there anyway to help us to read it. But it actually goes halfway between 300,000 and 500,000. How many viewers would that actually be?
400,000.
400,000. So 400,000 watched Chums. Annie watched Count Up at 8 o'clock. Let's use the line to help us. And that takes us to halfway between 500 and 700, which would be
600.
600. So how many more viewers are there at 8 o'clock than there were at 5 o'clock? At 5 o'clock we only had 400. How many were there at 8 o'clock? How many were there?
600.
600. So the difference is 200,000. Good. So there's a difference of 200,000 between them. Okay. Then it asks us, which time had twice as many viewers as 6 o'clock? Let's find 6 o'clock first of all. Use the lines to help us. We could use a ruler, but we've got the line to help us. And at 6 o'clock there were 300,000 viewers. So to be twice as many as that, what's twice 300,000? Double 300,000. 600,000. What time were there 600,000 viewers watching the programmes?
8 o'clock.
8 o'clock. Good, well done. Because there's the 600,000. Actually, if I'd used a ruler, that would have been much easier, wouldn't it? I could have gone straight from 600,000 and across and then followed the line down to 8 p.m. Good, 8 o'clock. Okay, let's have a look at the next slide. Still got Ron and Annie. They're still watching different programmes. Discuss what is on the x-axis, what is on the y-axis, what is the scale. We have just talked about that. Which one is the x-axis?
The bottom line.
Good, yeah, you're doing the actions. Yeah. Well done, yeah, it's that one. It's what we call the horizontal line. It's that one. It's the one that you change. Okay, that's the x-axis. Which one is the y-axis? Nice and easy because it's got to be the other one.
The up.
Yeah, well done. And you're doing the action for me. It's the one where you put the measure. There's something that you measure and get your temp measure. Yeah. In this case, we're measuring the number of viewers. Good. What is the scale? Well, that means how many is it going up by each time? How many viewers? How many viewers is it going up by?
Every 200.
Yeah, good. So, yeah, they've written the scale every 200. So it goes from 1,000 to 100,000, 300,000, 500,000, 700,000, 900,000. It's going up 200,000 viewers each time. But then in between, you've got the individual 100,000. So 100,000, 200,000, 300,000, 400,000, 500,000. So it's actually going up in 100,000s, but they've marked it every 200,000. Does that make sense? Good. Right, so we've done a lot on line graphs. That's a little just recap on line graphs. We're now going to look at pie charts. Let's have a look at the next slide. What is a pie chart? Sounds exciting, sounds like something you can eat. To me it sounds like apple pie.
It's a pie chart where you have a hole, and then it's like with a company, you have different parts of the company, and then it all makes a whole.
Yeah, good, yeah. So yes, it's a very different type of representing data. The line graph is very different to the pie chart. The pie chart, as we've just heard, is the whole thing. So that whole circle represents the whole thing. Now, at Copingham Primary School, there are 600 pupils. So that whole circle represents 600. There are 600 pupils, okay? And it's been nicely divided. The pie charts are useful because they're very clear and easy to read. Sometimes they can be a bit more complicated if you've got to draw them because you need to represent things very accurately and they don't always represent well in a circle. But if it works, it's very clear. And as you can see, we've even got colours to represent things. So this is how the children get to school. And you can see straight away how many children walk. How many children do walk to school?
300.
Excellent. How do you know?
Because it's half.
Yeah, we know that the whole thing represents 600 pupils. So if half of it is coloured in for walk, which is blue, then 300 pupils must walk. Okay. Then if you look at train, what can you see about the fraction? We need our fractions again for this. What fraction is coloured in yellow?
A quarter.
A quarter. What would a quarter of 600 be?
150.
150. So we know that the children who travel by train were 150. So we've got 150, we've got 300. Now, how would we work out what the green section, the green section represents, the car section? If we know that the quarter is 150, how could we work out this one?
Only half 150.
Good, which is
75.
75, yeah. We know that that is 150. We know that that is half of it. Well done. So that's 75. And if the car travellers are 75, what do we know about the cyclists?
It's the same.
It's the same, 75. So just by using our fractions, we can work out how many pupils did which activity or which mode of transport. Okay. So, what information do you know about a circle that could help the questions using pie charts? Angles, yes, more so for drawing than actually interpreting. All right, we know that there are 360 degrees in a circle. That really helps when we come to draw a pie chart, more so than interpreting, although it is sometimes useful for interpreting. But for this one, because it was a nice straightforward one, we could just use our fractions, couldn't we? A half, quarter, and then we've got eighths, 2 lots of eighths. Okay? Right, next slide. Classes in Year 2 and Year 5 were asked what their favourite drink was. Here are the results. That's the result for Year 5, and that's the result for Year 2. So the choices were Fizzerade, Roller Cola and Vomto. Strange sounding drinks. Okay.